Yo, day 10 of the IoT boot camp, hardware design. Day 10 of the hardware design IoT coding boot camp. Look, I want to make a clarification. I don't believe anybody in my class is paid for this boot camp. I believe the Deep Dive Booting Code Camp has an initiative where they collaborate with grantees that, pay for students that, are eligible for, the grants under those certain guidelines. And so I believe that everybody in the class is actually taking the boot camp for free. And isn't that amazing? When you have other boot camps out there that are charging people up front to pay or charging them after they get a job. I think we at New Mexico, and we here in Albuquerque, New Mexico, and I'm gonna validate this. I don't think anybody has paid for the boot camp at all. So, with that in mind, it's the end of the week, and look forward to showing you, what we came up with today and what we have planned for today. So, stay tuned. Peace.
Yeah. It'll just be your email, and it'll ask you to. Yeah. It'll just ask you to do that. Oh yeah, it's longer. You can click it while still loading, it will crash. Is it? So it's when I load it, it's a 30-day trial. There's a personal use. They give you an option to subscribe.
And so what those are encoders, which is what you have in your hands here. And so you can play with it. If you twist it, you can see you can twist it forever in one direction. You can twist it forever in the other direction. And what the encoder is doing is it's counting. These have 96 positions.
That's where it stops.
It doesn't stop. It keeps on going. But there's 96 discrete positions in this encoder. And what our software will do is, what it tells it is, am I going up or down is essentially the signal you get out of it. Am I getting a +1 or a -1? And so you can, if you just keep on spinning it, you can count to infinity. Or you can count down from infinity to 0.
So whenever power is applied to it, it sets that as a starting point?
Yes. It does not know where it's at.
Okay,
All
so
it knows,
just recognizes
all it knows,
path.
did I turn it 1 click clockwise or did I turn it 1 click counterclockwise? It's the only thing it knows.
Who soldered these? The top.
The gentleman in the back did. Okay? I asked them to do it yesterday just to kind of catch us up a teeny bit.
These look really good.
Okay? So, so again, 96 little positions in here. That number is going to be important because your pixel ring only has 12 pixels on it. And as you might imagine, we're going to turn the knob and have the pixel ring light up. But 1/8 of a turn on here is a full turn on your pixel ring, and so we're going to have to scale it down a little bit. We're going to have to make 8 clicks, 1 pixel. So put that in the back of your mind for a second, okay? So let's talk about so these also have other things in them, okay? If you push on the knob, you'll feel a little click. Go ahead and do that.
Yeah.
That's a button. Okay, so we have an encoder knob, and we have a button. And there's a pin called SW in the center of the 5 rows on the top. For those who can't see, just trust me that it says SW. That's the switch pin, just like your buttons before, okay? There's also a G and an R pin. There's 2 little LEDs in this encoder. So it can light up red, it can light up green, or if you turn on both LEDs, it'll be yellow. So we could click it, and it goes green, saying that my lights are on, and then I can turn my lights up by using my set brightness command, or I can turn it down by going counterclockwise, or I click it again and it turns red and the lights are off. So I have the rotary encoder, I have a switch, and I have 2 LEDs all in this package.
How many pins are we gonna need on the TC for this? All 8?
You are not gonna need. I don't think you're gonna. Well, you might need all 8. You're definitely gonna need 7. I'm just trying to think if we have to give it power or not based on the way we're wiring it. You guys are gonna need. Yeah, we're gonna need all of them because you're gonna need to send power into it too.
Okay.
And I'll get to C. I'll get to the C. I'll get to the A, B, and C in a second here. So on the top row we have ground. I think the one next to it is where our power is going to come in, a switch, and then a red and green LED.
Is
All in that little
is
package.
that the top 3 or 4?
Or 5. Okay. On the others, then the bottom side, then there's a side of it with 3 pins, and they're labeled A, C, B. So let's talk. That's the encoder part of this. So let's talk about how an encoder works. Okay. In the encoder, there are basically these metal plates that take the power and they connect the 2 outputs at different times. So when the encoder is in this position, neither one of the outputs are connected to. And so they are, and there's a pull down resistor in it, so they're ground. When I turn a little bit clockwise, the plate covers the first pin, pin A, and pin A goes high, but pin B is still low. I turn a little bit farther, I'm now on both pins. Pin A is high, pin B is high. I turn a little bit farther, and I'm on just pin B, but I've uncovered pin A. So pin A goes down, but pin B is still high. And in the next click, I'm back into this position and both are low.
Okay.
Is
So
that-
yeah, so directional matters because if it covers output A first versus output B first,
Yeah.
it knows which way to go.
Yeah, and we'll talk about that in a second.
Okay.
So let's just get this idea that the 2 outputs are covered separately. Does that make sense? Right now,
Day 10. Day 10. IoT coding, hardware design bootcamp. Day 10. This is the 2nd week. We're done. 2 weeks. 8 more weeks to go. 8 whole weeks to go, but I'm learning a lot. I'm getting a lot of help, and support from my instructors and the people at Deep Dive Coding.